All right, countdown's over. Let's go ahead and get started. Hickman, if you want to move us forward here. Okay, welcome everybody. My name is Bobby Henderson. I work here at Long in our hydronics and plumbing group. I want to thank you guys for taking some time out of your day today. I know everybody has a busy schedule. Today, I want to welcome Hikmet Demiriol and Bruce McDonald from Weishaupt Corporation. Today's topic is achieving low NOx in today's boiler plant. So without further ado, I will hand it over to Hikmet. Hikmet, go ahead.
Welcome, ladies and gentlemen. Thank you for joining us today. My name is Hikmet Demiriol. I'm the sales manager for North America for Weishaupt Corporation. Weishaupt is a burner manufacturer. We manufacture approximately 100,000 burners a year with headquarters in Germany, and we have offices all over the world. As Bobby mentioned, today I will talk about the NOx control strategies on boilers. So NOx can be considered as different forms of oxides of nitrogen. So in combustion process, NOx consists of nitric oxide, which is NO, and nitrogen oxide, which is NO2. There are other pollutants generated by combustion process, such as carbon monoxide, particulate matter, PM, volatile organic compounds, VOC, but NOx is probably the most regulated pollutant by authorities, together with carbon monoxide today. NOx is harmful both for people and vegetation. Basically, that's why the authorities pay a lot of attention on NOx levels. Long-term exposure can decrease lung function for people, increase the risk of respiratory conditions, and increases the response to allergens. It reacts with other pollutants in the air, such as like PM or VOC, and in the presence of sunlight, it can form ground-level ozone, which we know it with its common name, smog. That is the typical brown cloud that covers larger cities and produces basically poor air quality. As you know, Los Angeles is ranked as #1 for the number of high ozone days out of 226 metropolitan areas in the United States. I don't really want to scare you, and you might know that already, but Denver is ranked #8, tied with Salt Lake City for the number of high ozone days in the same category. Nitrogen oxide can rise very high into the atmosphere, where they mix and react with water, oxygen, and can cause acidic rain. And that can also have a significant effect, negative effect on vegetation, including leaf damage and reduced growth. I show you here a small slide where you can see an overview of required NOx levels in each state. As you can see, the state-regulated NOx levels are strict, more strict or stricter at the coast, like at the West Coast or East Coast, with some exceptions like Texas and Arizona. The EPA, which is Environmental Protection Agency, also regulates the NOx levels at the federal level, but usually their requirements are more looser than the state requirements, which starts at 30 ppm and go higher, even up to 200 ppm in some applications. Combustion needs two ingredients to understand the NOx emissions and where the NOx is coming from in the flue gases. Basically, combustion needs two ingredients, which is air and fuel. So the NOx comes, or the nitrogen comes from this ingredient. So there's a fuel-bound nitrogen, which is mainly concerned for fuels like coal, oil, or waste fuels. And for natural gas, it's really very limited nitrogen content. So that's not a concern mainly for natural gas, but also a portion of NOx, and maybe an important portion of NOx, is coming from the air, which is the combustion air we use for combustion. So as you know, close to, I mean, over 70% of air consists of nitrogen. So that basically contributes to the Knox formation in flue gases. There are two types of Knox that's generated in the combustion process. One is the thermal Knox, which is basically created because of high temperatures in the flame, in the combustion chamber. And the other one is prompt Knox, which is formed from molecular nitrogen in the air, combining with fuel-rich conditions, and which exists in almost any combustion process. Regarding the amount or level of Knox in flue gases of a boiler depends really on different factors. Maybe the most important factor is flame temperature, as I mentioned. Generally speaking, the higher the flame temperatures are, the higher the Knox levels the burner or the boiler will be. So as an example, if you think about propane versus natural gas, propane is a fuel that has higher flame temperatures. So therefore, a burner operating or a boiler operating with propane will have a higher, in general speaking, everything being equal, will have a higher Knox level compared to natural gas. Another parameter to observe is the excess air. Many manufacturers use high excess air burners to lower the Knox emissions, because excess air, basically the additional air you introduce to the combustion, will reduce basically the temperature of the flame, and therefore you will have a burner that has a lower Knox level. However, that has some disadvantages. If you increase the excess air in the combustion process, you will sacrifice the efficiency. So a burner, let's say, operating at 7-8% O2 levels will naturally have a lower combustion efficiency compared to a burner operating at 2-3% O2 levels, which is actually considered as the optimum level of oxygen in flue gases for combustion process. There are other factors which at the end of my presentation, Bruce will talk about, like flame geometry, the response time, which means the speed of the combustion, the medium temperature, the high combustion, the combustion air temperature, and the humidity level, as well as the combustion chamber dimensions. I will leave that to Bruce, so I'm not going to get into detail, but just as an example, for medium temperature, for example, a high steam pressure boiler with higher media temperature will operate at Knox levels that are higher than a condensing boiler. So using condensing boilers, beside the efficiency, they have the advantages of operating at lower Knox levels. As Weishaupt, as I mentioned at the beginning of the presentation, we are probably the largest burner manufacturer in terms of turnover worldwide. We invest a lot in our R&D, and we manufacture burners with highest combustion technology. But in reality, the principles we follow for controlling Knox is very similar to the methods of cooling of a campfire. Maybe that's that's a little bit too simplifying, but we basically, to cool off the campfire, you spread out the coals, you stir the coals up and spray it with water. We do the same with the burners. So we spread the flame out, which means we play with the geometry of the flame. We stir the flame up with mixing with surrounding gases, which I will come. And we also add a coolant, like additional combustion flue gases we get from the stack of the boiler, introduce it to the burner and reduce the flame temperatures. So here is an example of a technology we call multi-flame, which is a patented technology for us. It basically consists of, instead of creating one big flame for the burner, we basically create different zones and multiple flames to reduce the flame temperature. So That is like spreading out the flame and playing with the flame geometry to reduce the temperatures of the flame and the NOx levels. Another method we use, which is, with this one, we can reduce the NOx levels below 30 ppm approximately. So it can be 30, 25 ppm. That doesn't require an FGR, and it's just with the burner design. We also have another method we call FGR, and which we use for different type of burners. We can reduce the NOx levels below 15 ppm for those with those burners. What we do in this case, we just, as you can see, with basically a line, a pipe, some piping, we bring a portion of the flue gases back from the stack to the burner, and that will have an effect basically as a coolant and to reduce the flame temperatures. So that is a very common method to reduce the NOx levels, and we can reduce the NOx levels to 15 ppm or below with that technology. The last technology I will talk about is what we call a mesh burner head, or some people use as a premix as the terminology. This is mainly used for single fuel burners, which is gas only, either natural gas or propane. You basically create a big surface and thousands of little flames on that surface burning at the same time. And that way, with smaller and multiple flames, you can reduce the NOx level to single digits, as below 9 ppm. So this is a very well-known technology, and really very old technology from many years ago. The downside of this, as I mentioned, is that these burners usually operate at very high O2 levels, as well as they have a very limited turn down. So you will have to start and stop the burner pretty often, and that means you will increase the fuel consumption compared to a regular burner with 30 ppm or 15 ppm. Thank you for listening to me. I mean, if you have any questions regarding these technologies, please contact your correspondents, the engineers and sales personnel at Lone Building Technologies. They will be happy to help you, I'm sure. And if there's anything we can help you with, please contact us as well. Thank you, and I will leave it to Bruce now.
All right, great. Again, thanks for taking the time to join us. I'm Bruce McDonald, the Technical and Applications Manager at Weishaupt. I just wanted to point out a couple of things to really consider as we start bringing this equipment into the field, some of the gotchas, if you will. Hikmet mentioned the furnace dimensions, and that is absolutely crucial for this to work. In order for that recirculation to take place and that magic to all happen, we have to have particular furnace dimensions. It's also important when you're measuring a furnace to recognize that we have the thickness of the materials and corrugations. If you're looking at the documents from the boiler manufacturer, typically those are showing the outside dimensions, where we're actually interested in the actual free space available to the flame. And that can be, 3.5, 4.5 inches less than what's on the boiler manufacturer's document by the time we again add the thickness of the material and the corrugations. So definitely pay attention to that. Hikmet mentioned earlier media temperatures. If we're running a very hot thermal oil or something like that, certainly more difficult to achieve our NOx. In practice, this means when you're setting one of these things up, if it's a high pressure steam boiler, make sure you're actually at the operating pressures, or with water or thermal oil or something, that you're actually at the operating temperatures to make sure that we're not making a mistake and getting a false reading. Ambient air temperature can make or combustion air temperature can certainly affect this. So that's something to keep in mind. And again, humidity. That's another thing. As we increase the humidity in the air will act as a coolant as that humidity is burned off. So often you will get beautiful low readings in the morning, and later on in the afternoon your NOx will start to creep up, and that's because the humidity tends to change in that fashion in most locations. So those are just a few things to kind of keep in mind, just to make sure that some of the maybe less than intuitive things don't creep up on you. That's pretty much it. I don't want to take up too much more time here. It looks like we're running at the limit. For certain, when putting one of these things into operation, beforehand, if there's any questions about some of the quirks and gotchas, that's what we're here for. And after the fact, if it's not working out quite like you'd expected, again, that's what we're here for, to help iron out those bugs. So there we go, Bobby.
All right, and that does it for this week. So thank you all very much. Please join us next week with the one and only James Murphy, talking about high efficiency heat recovery at extremely very super duper low ambient temperatures. And of course, 2 weeks from now, go to the next slide here. Let's see, the open house will be at Long's parking lot here in Littleton. So hope to see you all there. Please, if you haven't registered already, please do so. You can contact your Long salesperson for the registration link. Thank you all very much and have a great week. Take care.